Now let's talk about the cross product. We have two vectors here. It says let U equal U1, U2, U3, and V equal V1, V2, V3. And this is in the cross product of U cross V. That's how you say this. You say U cross V is a vector, and the vector is this here. I also wrote the component form of it down here. So I'm more comfortable with the component form, so I'll probably use that. If you have any issues or concerns with that, please let me know. So from there, this is just a formula. I never memorize this formula. I always think of the cross product as a determinant. And what I'm going to do is I'm just going to show you how I'm going to work that out. And it comes up with the same thing that you see here, but this is something I can do without memorizing this complicated formula to begin with. So I set it up this way. I go I, this is J, and this is K. And then essentially I just write the vectors below. So the first vector is U1, U2, U3. And my other vector is V1, comma, V2, comma, V3. It's more difficult with the letters in there like this, but if I had the numbers in there, this would be really fast. So this is just going to be a little painstaking. So then what this would mean is I would treat this as a three-dimensional vector. And how we compute the determinant for that is I freeze the first entry. And then what I'm going to do thereafter is I'm going to take this matrix here. So I'm just going to write that here. So that's going to be then I. And then I'm going to have the matrix U2, U3, V2, V3. Now again, I'm just writing all this out. So again, initially this seems confusing or complicated, but as you do a few of these actually get really fast once numbers are in there. And that's the I. Now the second component, once I pick that, I usually have I do have an alternating sign here. So that means this here is positive, this here is negative, and this here is positive, just from the process itself. Okay, so I'm going to call this a negative J for that reason. And then now I'm going to take this entry here, and I'm going to block out this here. So then my matrix is going to be composed of these four entries. So let's see how that works. So I got my J there already. So now I'm going to have the vector U1, U3, V1, V3. And then the last one, I'm going to take my K here, plus K, and then I'm going to have this here as my matrix. So that's going to be U1, U2, V1, V2. And that's going to be my third one. So now to find a determinant of a 2 by 2 matrix, I take these two here, I times them, and I subtract the product of these two. So then what that looks like is, I'm going to keep my I here, but this means I'm going to have V3 times V2, or U2. So U2 V3 minus U3 V2. And then I have my negative J here. And that's going to be those two first. So that's going to be U1 V3 minus U3 V1, and then plus my K, which is going to be V1 or U1 V2 minus V1, or I'm sorry, I do my U's first. U2 V1. Okay, now if you notice, that's exactly what I have up here. And for each of those. So now my other form for this, which is just going to be exactly what I see up there, I'm going to get exactly what's above. So there we go. So now that's a nice way to think of how this works. Now again, this wasn't a very easy process because it seems like a lot more steps than just following the formula. But I want to show you something here. So this problem, we're going to find the cross product of U cross V, where U is 350 and V is 2, 40. So I'm just going to take one and write it over the other. But first I'm going to put my IJK. IJK. And like I said, I think of this like a cross product. Like a determinant, I'm sorry. It is a cross product. So I'm going to have this here. And essentially the way I think of this is I want to take this entry first. So that's going to be my ith component. So that's my first component when I'm talking about component form. So the way I work that out is I just take and I'm going to eliminate this column here. And my matrix I'm looking at is going to be this one here. So if I just take my finger and cover up that first column, and just simply thinking about the timesing here, when I'm doing that determinant here, I'm going to get 5 times 0, and it's going to be minus 0 times -4. So I'll write that out for you. So that would end up being 5 times 0 minus 0 times -4. And that would be the first entry. And we know it's going to be 0. And then for the second entry, I cover up the second column with my finger. And I'll get, and remember for this one I have to negate it. So whatever I get, it's going to be minus. I'll use a bracket. Okay, and then that would be 0 times 3. Minus 0 times 2. And then for the third, and then covering up the third, I'm going to get 3 times -4 minus 2 times 5. And that's going to be my new vector. So to simplify that then, that equals 0, comma, -0, but 0, comma. And then for the last one, I'm going to get -12 and -10. So -22. So I just kind of want to run through this really quick for you again. So I cover up the first one, and I get 5 times 0 minus 0 times -4, and that's 0. Then I cover up the middle one, and don't forget to negate it. And that's going to be 0 times 3 minus 0 times 2. And then I cover up the third one here, and that's going to be -4 times 3 minus 5 times 2. So that's how I kind of think of these all together. So to come up with these calculations really aren't that bad when I start to think of it that way. So there's a video.